Hello everyone. This is a video lecture for College Algebra Math 1314 Section 2.6 Domains and Composition Functions, I suppose. So, let's get to it. Question number 1, it says find the domain. Well, there's two things that we should be looking out for when we're looking for domain. So on the side, I'll just remind you, if we're ever dividing by 0, that would be undefined. That's no good. You just can't do it. If you have a square root of a negative number, you might think it's imaginary, but that's not part of this class. Here, it's undefined, and you just don't do anything with it. So we're looking for two different instances that might occur, and I basically label them as division and square roots. So we're looking out for division and square roots. So does this have division? Yes. And so we're going to have to do something with it to find out when it might have this divide by 0 stuff. But does this problem have a square root? I know it has a square, but it does not have a square root. So I just have to ignore that one. We'll do that one later. There's got to be like a mini formula for each of these. So I'm going to say that the bottom is equal to 0 is basically going to find your holes in the domain. And for square roots, I often just say it's the inside equal to 0. And that's where you're going to have a start point. So I'm just going to do hole and start. Okay, it's just rough. It's not perfect, but it's a good start to what we're wanting to do. So again, does this have division? Yes. So I'm going to take the bottom off to the side and set it equal to 0. I'm going to solve for x. Well, the easiest way to do this is to factor it. At least I hope so. That's the goal, is going to make it a little easier. So what two numbers multiply to 48 but add up to 2? Well, we got 12 and 4 does not make it. Is there a 6 in there? Again, you can use a calculator to kind of help you out. 6 and 8. Yep, 6 and 8 will work. So this is 6 times 8, and this is something with 6 and 8 to make a 2. And so that's a negative 2. I'm going to make a negative 8 and a positive 6. And that way you should add to the negative 2, but yet multiply to that negative 48. And so we have our answers, x equals 8 and x equals negative 6. And both of these are going to be a hole in the domain. Now, if it were just easy, like putting 8 and negative 6 in here and walk away, that would be nice. But the program's going to want you to do a lot more. It's called interval notation. Interval notation. And it's not terribly hard, but you have to kind of know what you're doing. And so this is how it would look. This is your answer. Negative infinity all the way until negative 6. And then you do a union. Negative 6 to the 8. Union 8 to the infinity. And that's your answer. Now, I know it looks like a lot, but what's going on is that these same two numbers just keep popping up here. I think of it kind of like a number line, and negative 6 is the first one that happens as we're reading left to right, and the next one that happens would be the 8. So negative 6 must come first, and then the 8, and so all of this language here is just saying, you know, there's a x equals negative 6 as a whole, basically. All of this language here is saying that x equals 8 as a whole. That's all it is. It's almost copy-paste. You can see that you would have a number, union, number, number, union, number. And that's just how it works. So duplicate that however you need to. Next question. It says, find the domain again. So I'm going to ask a question. First off, does this have division? No. So I don't have to do that divide by 0 stuff. But does it have a square root? Yes. And so I need to take the inside equal to 0 and solve for x, essentially. Now remember how I said that this would be a start point. So let's go through and see how this will work. So first off, I'm going to add a 45 to both sides. Divide by the 3 to get 15. And I'm going to call it my start point. Because if you plugged in 15 right here, it actually would work. So like 3 times 15 minus the 45. If you did it, you get square root 0. But what's the square root of 0? Try it in a calculator. It's 0. That's it. It works. This is good. This is a good number. We want to use it. 16 will be fine. 17, 18, all these numbers. But 14 is no good. And even 14.9999 is no good. And so there's got to be a way to put this into interval notation, to a different kind of like math language. So there is. All you need to do is square brace, or bracket if you want to call it that, 15 to infinity. And that's it. That's the entirety of this problem. Very simple. And so 15 is that start point. You can see I'm starting at the 15. This, I call it a square brace because it's a square root, square brace. That way you kind of remember it. I know bracket, that's fine too. And so that says that you're starting at 15. 15 is a good number. You want to include it, okay, back from our earlier sections, and then you go on to infinity. Okay, so that's pretty easy. But the next one is similar, but it's a little different. So does it have division? No. Does it have a square root? Yes. And so I'm going to take the inside and set it equal to 0. What I'm going to do is add the 3x to both sides. And I'm going to divide by the 3. So we get 8. And again, this should be a start point, but it's not. It's an end point. What? It's all of a sudden really weird. Well, the quick version is that you can see that this is going to be a negative x. The x is negative, and therefore it's a horizontal reflection. I guess instead of having the square root normally do this, now you have it going this way. And so it's ending at that point, not starting. Again, if you're reading left to right, it's ending at that point. So the answer is going to be very simple. It's going to be negative infinity till the 8, and then you're going to have a square brace. And so that's what you're going to have to do on this case. Now that's all just very technical, and it's kind of using the previous sections that we already learned, and that's fine. I would say that there's another method to doing all this. And so if you drew a number line, and 8 is somewhere right here, well, let's go ahead and just put it in the middle. I need to test points that might or might not work. So I'm going to ask you, what's an easy number that's less than 8? And you could say 7. That's totally legitimate. 5 is good. What about 0? 0 is pretty easy. So I'm going to pick 0. And now let's pick another point that's bigger than 8. And see, 9 is easy. What about 10? 10's easy too. Let's just do that. It doesn't matter what number you're using, just as long as you're using something here before 8 and after 8. We're going to just test each number. So f of 0, I'm just plugging it into the original here. So 24 minus 3 times the 0, square root of 24. I don't know what that is, but it's a number. It works. I guess here, just to prove that it works, let me use my little calculator to see what it is. It's a decimal. I got 4.8989 . It worked. I mean, that's fine. That's good. So in a way here, this 8 is kind of like the cutoff line. Everything over here works great. Okay, I tested a number. It works. I like it. But what about if I tested that 10? And so I'm going to say the square root of 24 minus 3 times 10. That's the square root of 24 minus 30. Square root of negative 6. You can see right here, that's no good. So everything over here is no good. I want to include this in my answer. So again, from negative infinity up until the 8, and then it stops. So that's a more lengthy description of what's going on. Not required, but there you go. All right, another question. Number 4. So they give us these two functions, and they want to find all of the stuff. And you can see it's going to keep going. It's a lot of stuff here, and that's fine. So let's go through each of these. It's actually very simple. When they say f plus g, they actually just want to add those together. And so I've got my 3x squared plus the 7x plus the 4. There's my f plus my g, x plus 1. F plus g. That's all it is. Combine like terms to simplify, right? And so you got the 3x squared. These will combine to make an 8x, and then those will combine to make a 5. And there's your answer. It's very simple to do this stuff. As far as domain, and this is almost going to be default answers here, do I have any division? No. Do I have any square roots? No, I have a square but not a square root. And so your default answer for most of these is going to be negative infinity to positive infinity. That's basically a default answer saying, hey, there's no problems, there's no division, there's no square roots. We should be good to go. As far as the subtraction goes, now I'm going to use parentheses. The last time I didn't need to, but here I need to differentiate between the f and the g. You don't really need parentheses over here, but you need them here on this side to be able to distribute the minus sign. And so now you get a negative x minus 1. Combine your like terms again. 3x squared, now plus 6, and then plus 3. And that's your new answer. Again, is there any division? Is there any square roots? No, no. Negative infinity, positive infinity. Okay. I'm going to just bring this over to the side. When it has f, g right beside one another, that's f times g. You're going to be multiplying them together. And this will definitely take a little bit more room. So I'm going to just kind of write it out. Okay. And now let's go and tackle this on the side because it's going to be pretty lengthy. So how do I simplify this guy? Well, you FOIL it. FOIL is a technical term, first out, enter last, something like that. But the main thing is that we're going to be distributing everything we have to each term. And it's going to be slow. So here we go. 3x squared times x is 3x cubed. 3x squared times the 1 is 3x squared. 7x times the x is 7x squared. And 7x times the 1 is a 7x. 4 times x is 4x, and 4 times the 1 is 4. Combine like terms, and so my answer should be 3x cubed plus 10x squared plus 11x plus 4. There we go. Whew, that's pretty lengthy. Okay, but now my question still arises. Do I have division? No. Do I have a square root? No. And so when they ask for the domain, just the default negative infinity, positive infinity answer. Okay, last one is this division stuff. So I need to take the top and the bottom, and I'm going to divide them now, kind of like this, putting g on the bottom. And then I need to simplify this guy. Okay, so I don't quite know how to simplify this one just by looking at it. Do I factor the top? Is there a way to cancel things? It's kind of difficult, actually. And so here's the thing. I am going to assume that the top will cancel with the bottom somehow. And that's just how this program that you're using for your homework is going to work. You need to assume that the top will cancel with the bottom. Okay, I'm just writing this out, I guess. You need to assume that the top will cancel with the bottom. What I'm trying to say is that this top, although it's hard to factor, it will be factorable, but the assumption is that there's going to be an x plus 1 here that will cancel. That's my assumption. The problem is I don't know what goes here. Okay, now we can go backwards to figure out what that is going to be, and so I'm going to reason with you on how to get that answer. But this is how you should assume it. Now, if it doesn't actually work, that's fine. We'll know pretty quickly if it doesn't actually do this. But this if it does cancel, then it simplifies. If it doesn't cancel this way, right here, then there's nothing to do with it, and that would be your answer right now. So in a way, this is the only route we could take. Might as well try to make it easy. And so if I have an x plus 1 here, what do I have here? Well, notice that we have a 3 in the front. And the only way to make a 3, if this is a 1, is to make a 3x right here. Okay, so I'm factoring it. I know that I have a 1, so the only way to make a 3x squared is to have a 3x here and a 1x to make a 3x squared when I start to FOIL it, you know. Looking at the last number, I got a 4. And so I have a 1 right now. The only way to get a 4 is to have 4 times 1. That's the only way to have that whenever you FOIL. It would look like this. So 4 times 1 is 4. So you have to have a 4 there. One last thing. Notice everything is positive. And so this is positive, and this will be a positive. Everything's a positive. If you have a negative, you might need a negative. It kind of just depends on the problem. But you would have to look and see, would a positive be better or a negative? And you can always verify this. I mean, if you want to, we got the 3x squared, 3x, 4x, and then the 4. Wouldn't that make a 7? And wouldn't that be the original? So it does factor. It does work. This is legitimate. Get rid of all that. And so if that's true, then these guys cancel. Those two factors cancel, and your answer is 3x plus 4. That's the simplified answer that they want. That's what the program's going to want you to type in. Okay? Now for the more technical side of the domain. If you go back, we got our answer here. Look, 3x plus 4. There you go. But they want the domain. And so I'm going to ask, looking right here, is there division? Is there a square root? And you're going to say, no, no. That's not really where we're actually needing to go right quick. We actually need to look right here at the original. And so I'm going to ask the same question. Is there division? And you're going to say yes. So I need to see whenever the bottom is equal to 0. And that's going to be at -1. And again, that's a hole in my domain. So how do I write out my domain with the hole? It's actually pretty easy. We just did all this. -infinity to -1 union, -1 to infinity. So that is your answer for the last part. Again, you just have that whole interval notation language there. That was a very big problem. And there's like 2 or 3 on your homework, so just watch out for that, okay? I tried to do a moderately harder one because there was a lot going on. Okay, another problem. So this is a little different. This is composition functions. Composition functions. Close enough. That's f of g. F of g of x. And so another way to write it, though they don't do this much in the program, is f of g of x. I like it like that personally. That's my favorite. But they'll use the little 0 circle thing. It's not a 0. It's just a circle, basically. But either way, you can see that my g of x is on the inside. And so that's what I'm going to do. I'm going to take my g of x and I'm going to plug it into the inside, into the x for f. Okay, so I'm plugging it in. And so my original f was blank plus 4, x plus 4. Well, now it's 5x plus 3 plus 4. So I just filled it in wherever there was a blank, wherever there's an x, wherever there's parentheses. I now have more stuff. 5x plus 7, and there you go. It's not hard. Now we have to go the other way, backwards. And so this here is the g of f of x. Let me use a different color. G of f of x. Notice that f is on the inside now. I'm going to take this and plug it into the x right there. And so my original is going to be 5 blank plus 3. Again, what goes inside the blank is going to be this x plus 4, and then plus 3. Distribute the 5. So 5x plus 20 plus 3, 5x plus 23 is your answer there. So we got our answers for part A and B basically, but we need to find these last two. And they're not hard. They're saying use the same answer that you had in part A for part C, but now we're changing it that x is now -2. And so to find this, I'm going to say the 5 times the -2 plus 7. I'm just plugging in wherever we had an x. Now it's a -2. It's just using the same formula, I guess you can say. -10 plus the 7 is going to be a -3. Same thing right here. For the last one, I'm going to plug it in for x, -2, yet again. It's got -10 plus 23 is 13. Okay, awesome. So composition functions. This is the same kind of question, but it's backwards. And they say that we have the answer already. the g of x is on the inside, while the f of x is on the outside. Find out what they are. So here's the total answer, and we're going to find the question. We're going backwards. So I'm going to ask you, here, let me just rewrite here. So g of x is the inside, f of x is basically the outside. And so I'm going to ask you, not on the outside, but on the inside. What's the inside look like? Just tell me, what would you say is on the inside? And you would know it's right there. It's x cubed minus 2. It's very simple to find the inside. And so I recommend doing the part B answer first, in a way. At least write it down. And then part A is now saying, well, what's on the outside? Well, let's just take what we had, and I'm going to get rid of the inside entirely. I'm just going to say, in a way, I have the fourth root of stuff. I don't know what that stuff is. It could be anything. I just had stuff in there. How do you say stuff in math land? X. And so that would actually be your answer for the outside, is the fourth root of what? You got to put something in there. X. Okay. Cool. So we went backwards. There you go. And another question. So this has two parts. It's actually on the homework. It's two separate homework questions, but I wanted to combine them because the graph and all that kind of stuff. I'm going to try to use different colors than what we already have up here. So f plus g at -1. -1 is right here. And so if you look, I have a height of 2. And I have a height of 3, 4, 5, right? And they say plus, add. So they're just saying 2 plus 5 is 7. Very simple. So at -1, find the heights and just add them. That's what they're wanting here. Now the f of g is a little different, because it looks kind of like that. Well, not of x. Technically, it's of 2. And so this is technically what that looks like here. And what I'm going to do is start replacing things that I know. I'm going to try to find first, what is g of 2? So I'm looking at the graph, and 2 is right here, and I want to find out what's the height there, I guess you can say. Actually, I think it's going to be closer right here to -1. So just kind of bear with me on that. My graphs are not perfect, but let's just say that it ended up that this line right here was at, here, I'm going to just use some blue so it's looking a little bit better. I know it doesn't matter. You understand what I'm getting at. I'm just wanting to be perfect about it. There we go. Now it looks great. Okay, so back to what we were doing. At 2 for x, it looks like it's going to be a -1 for my y value. And so what I could do is replace the inside with a -1. I replace the inside with a -1. Okay. I'm going to use a different color. This might be a bright cyan. Woo. And so now I need to, I guess I'm not just finding that. I'm finding this now. Find f of -1. So I replaced the g of 2 with a -1. And now I'm going to go to f is a -1. So there's my -1 right there. Find the height. Go up and over. And you can see it's a 5. And there you go. Sorry, it's so bright. So what I want to do instead is I just want to copy down what I was doing in another way. Not a different color, another way. So I have my g of 2. Again, I just want to remind you what I'm doing here. 2. I'm going to be finding out what the g graph height is, cutting over, and I found it was a -1. So I'm going to replace the inside with a -1. Well, now I need to find f of -1. So now I start at -1 for x. It's right there, actually. And I go up. I go over, and what's the height there? It's 5. So anyways, I just wanted to show you how this thing worked. You got a couple questions about it, obviously. And now for the last one, of course, it's got to be a hard question. And so there's a lot of words with this question and all kinds of stuff going on, but in the end, it's not too bad. They say find a difference function. Well, what does difference mean to you? It means subtract. You're going to subtract these guys. You're going to say f minus g, basically. And I would use a calculator to get this correct. So this one minus this one, notice that two negatives make a positive. It should end up being a positive 0.003x squared. This one minus this one, Oh, that's something I need to use a calculator on. So 0.16 minus the 1.62. Like on my calculator, what I'm doing is 0.61 minus the 1.62. And I found a negative 1.01x. And then these guys, 191, and then subtract this guy because, again, we're minusing these guys. So 191 minus the 138 is 53. Definitely use a calculator. There we go. So we found the difference function. Cool. That's part A. Part B now says use this difference function in 2060 if x is years after 2020. So how much x distance do we have between these guys? 40. And so what I'm going to do is plug in a 40. Wherever there's an x, I plug in a 40, and I'm going to get a number. I guess I can go and write out what I'm doing here, but this is definitely going to be a calculator situation. 40. Okay. Calculator time. 0.003 times 40 squared minus 1.01 times the 40 plus 53. And I've got 17.4. So there's my answer, 17.4. Part C now says compare with these guys. And so my original F and G values would be these guys. These are the actual values. And then we have our formula. And so does it over or underestimate and by how much? And so the difference for these guys would have to be a subtraction as well. So I'm subtracting those two. And I got 19. Okay, now that's not the answer. That's just theirs. Well, compare with mine. Compare with the formula. Mine is under and by how much. And so I'm going to now subtract those numbers. And I found 1.6. Again, how do I find that? I did the 19 minus the 17.4. Okay, so cool. And, well, that's it. That's all I got. So, thank you very much, and have a great day.